Hello friends, welcome to our channel. We know that when a plane mirror forms a virtual image, the image distance from the plane mirror is equal to the object distance from the mirror. Distance means perpendicular distance. Okay, this is 90 degree. So this is what we are going to prove. So I have drawn a diagram. Let us assume this is our object, one light one ray of light coming from it, and after striking the mirror it gets reflected towards the direction OC, and this is our normal OP. This is angle of incidence, this is angle of reflection, and another ray coming out of this object strikes the mirror perpendicularly. Okay, in this case angle of incidence is 0. That is why we can say the ray incidents normally on the mirror and it gets reflected in the same direction. That means angle of refraction will also be 0. Now if we drag these reflected rays backwards, they meet at a certain point B. So here the object can be here the image can be seen. So we are trying to prove the image distance from the plane mirror is equal to the object distance from the mirror. That means we are actually trying to prove this distance should be equal to this distance. Okay, we are trying to prove AD should be equal to DB. Now we can see that in triangle ADO and triangle BDO, number 1, angle ADO is equal to angle BDO 90 degree. Number 2, this is the mirror and these are two perpendiculars on the plane of the mirror. So these two perpendiculars must be parallel. Number 2, we can say PO parallel to AD. PO is parallel to AD and AO is the transversal. Therefore, we can say, okay, these two things are parallel. Okay, therefore we can say this is our transversal. Now, therefore we can say uh, angle AOP should be equal to angle OAD. Why? Because they are alternate angles. Number 3, again we can say This is a perpendicular and this is another perpendicular. Okay, that means we can say PO should be parallel to AB. Why? Because they are perpendiculars on the same plane. Okay, this is a perpendicular, this is also a perpendicular on the same plane, that is why they are parallel. And this is our transversal. CB is the transversal. Therefore, we can say this angle should be equal to this angle. Why? See the diagram carefully. This is a perpendicular. This is another perpendicular. These two are parallel. This is a transversal. So these two angles should be equal because they are corresponding angles. Okay. Therefore, we can say angle COP is equal to angle OBD. Okay. Why? Because they are corresponding angles. And AOP is I. So we can say this is angle I. And COP is angle R. That is why we can say this is equal to angle R. But from laws of reflection, we know angle I is always equal to angle R. Therefore, we can say this angle should be equal to this angle. That means angle OAD should be equal to angle OBD. So we have determined that these two angles are equal. Okay, these two angles are equal because 90 degree. These two angles are also equal because this is equal to I, this is equal to R. So these two are also equal. And OD is the common side. Therefore, we can say from this, and from these three conclusions, we can say from these three informations, we can conclude that is congruent to triangle BDO. Triangle ADO is congruent to triangle BDO. Therefore, we can say AD must be equal to BD. AD must be equal to BD. Okay. So why? Because corresponding parts of congruent triangles. CPCT. Okay. So this is proved. What we needed to prove. Now our next topic is lateral inversion. Lateral inversion means the phenomenon where the left and right sides of the object are reversed when viewed in a mirror. This phenomenon is called lateral inversion. We have seen when we stand in front of a mirror and we raise our right hand to comb our hair, it seems that we are combing our hair with our left hand. So lateral inversion is responsible for that. The right and left of an object get reversed when we see the image inside the mirror. This phenomenon is called lateral inversion. So if this is a mirror M1, okay, with this reflecting surface, then we can see a letter L. We have considered a letter L. So light rays are coming out from this letter. We have considered 2 points. Similarly, L contains many points, but we have only considered two for simplicity. So for this point, two rays are coming out and getting reflected. So when these two rays are dragged backwards, they are meeting at this point. Okay. Similarly, another point is considered, and the rays are coming out of this point, and after getting reflected, they are going to a certain direction. So when the rays are dragged backwards, okay, we get the image of this point. Similarly, all points of L create image inside the mirror. That is why we can see the point which is closer to the mirror will create an image which will also be closer to the mirror. So we have just proved that object distance is equal to image distance. So this point is closer to the mirror, so its image will also be closer to the mirror, and this point is far from the mirror. That is why the image will also be far from the mirror. Okay. So the letter actually gets reversed when the image is seen. Similarly, many other letters can get reversed, like P, B, C, K, F, etc. So we observe inversion. We observe an inversion. Sorry. So we observe a lateral inversion for these letters. Okay, but other letters such as A, W, X, Y, O, T, etc. suffer lateral inversion, but we do not differentiate, we cannot differentiate the image from the object because they are symmetrical. Okay, so if we cut W from the middle and if we reverse the right and left sides, it will look the same. That is why some letters which are symmetrical, when suffers lateral inversion, we are unable to detect that. Okay, so lateral inversion is observed for these letters, but for some other symmetrical letters lateral inversion happens, but we are unable to detect that. The image formed by a plane mirror has some characteristics. Number 1, image is upright. That means image सीधा होता है. Image is upright with respect to the object. Number 2, image is of same size as that of the object. Okay, lateral inversion is seen object distance from the mirror is equal to image distance from the mirror. So these properties are seen. Thank you, friends. Image formed by a pair of plane mirrors. So if we assume these are two plane mirrors, this is our mirror 1, this is our mirror 2. We can place an object in front of the mirror. This is our object. Now one thing to keep it so one thing we should keep in our head is that the object and the image formed by such mirrors always lie on the circumference of a circle whose radius is, okay, let us assume this is the point of intersection of these two mirrors. Okay, this is our point of intersection. Let us call it point P, point of intersection. And if we join these 2 points, okay, we are getting a line segment. And by using this line segment, if we draw a circle, okay, we are taking this as radius. If we draw a circle, something like this is our radius, the line segment joining the point of intersection and the object. Okay, this is our radius, and by taking it a radius we can draw a circle. So the object and the images, for example, this is our image I1, okay, this is another image I2, okay, something like this. So object and images will lie on the circumference of this circle. Okay, this is a very important point to be noted. Remember it. Now if we call this angle theta, okay, the angle between these two mirrors is called theta. Now if we divide 360 by theta, 360 degree by theta, we are getting something. Okay, now we can represent it by x. Okay, when x, that means this quantity 360 by theta, when x is even, the number of images formed is always x minus 1. And so this is the case when x is even. Now if x is odd, then two cases can happen. Case 1, when the object and the point of intersection, these two points are joined, and this line divides this angle into two equal parts. This angle is equal to this angle. That means the object is placed symmetrically. When the object is placed symmetrically, the number of images formed is again x minus 1. Case 2, the object now is placed asymmetrically. That means this angle is not equal to this angle. These two parts are not equal. Then the number of images formed is equal to is x, one more than the previous case. Okay, so I hope you have understood it. When 360 by theta is even, that means x is even, then number of images is x minus 1. When x is odd, case 1, when object is placed symmetrically, number of images x minus 1. And case 2, when object is placed asymmetrically, the number of images is x. Okay, now let me give one example. If theta is equal to 60 degree, x is equal to 360 degree by 60 degree, that means 6. Therefore, so this is even. Therefore, the number of images formed is equal to 6 minus 1 equal to 5. Now, if theta is equal to, let us say, x is equal to, theta is the angle between the two mirrors. Okay, when theta is 40 degree, then 360 degree by 40 degree, this is 9. So this is actually odd. Okay, now we can say when the object is placed asymmetrically, number of images equal to nine. When the object is placed symmetrically, number of images equal to 9 minus 1, that is 8. Okay, so in case of odd we are getting two different results. When the object is placed asymmetrically we are getting same number of images as x, and when the object is placed symmetrically then we are getting number of images 1 less than x. Okay, because when we place it symmetrically two images overlap, that is why we observe one image less than the previous case. Okay, so when we place it symmetrically two images actually overlap and become one. Now if theta is 75 degree, then x equal to 360 degree by 75 degree. This is 4.8. So in this case we are getting 4.8. So the number of images formed will be we should take the we should avoid the decimal part. So we are only taking the whole number part, that is the number of images formed is 4. So when it comes in a decimal number we only take the whole number part. Thank you friends for today.